Module 6. It's about documentation and deployment. Here we are dealing with produce milestone documentation and manage the project history using source control and produce the results and making some demonstration. Okay, first about producing effective milestone. Milestone is a readable summary of project goals and its steps taken and the technical results. Actually, it is created using R-Knit package, and this one produces a reliable snapshot which shows the state of the project and allows to confirm the project work. And it is read by collaborators and peers. It should be concise. Various ways of forming effective milestone includes using Knitter to produce documentation, then use effective comments, using JIT for version management, and for deploying models as HTTP services and exporting model results. So after creating an effective milestone documentation, you need to manage the project history. Suppose you are required to check how your project is worked during February. For this, that is, for checking checkpoint documentation, you need a good version control. So after creating a milestone documentation, you need to manage the history. After that, next step is deploy demonstration. So deploy demonstration is done by experienced engineers. Engineers must know the tools and environment, and based on experience of his work, text corner cases and build acceptance, he will be able to deploy the demonstration. The database used in this model is the bus dataset from this site. So what are the attributes of this bus model? First one is rows. Rows specifies various different measurement of popularity of a technical personal computer. Next is topics. Topics include the technical issues about personal computers such as brand name, memory and overlooking. Next is measurement type. It includes the quantities such as number of discussions started, number of posts, number of authors, number of readers, and each measurement are taken at 8 different times. Then next is times. 8 relative times are likely days. So all the 8 relative times are stored in different fields in this same data row. One more attribute is there, that is bus. The quantity to be predicted is called bus, and it is defined as being true or 1 if the ongoing rate of additional discussion activity is at least 500 events per day, averaged over a number of days. Aim of the bus problem is to predict the future variable based on the past experience. So, a domain-specific reshaping of the supplied variable is sufficient. Suppose you are considering the popularity of articles over 8 days. Here, popularity summed over the measured days represents the variable, then age, shape, times, series specific are the other specified variables. Using meter, how to prepare the documentation. So our aims are we need some goals and we need to know where the data came from and what are the techniques used. So in order to prepare the documentation, we need these three things. So you have to use standard terminology or references. You can emphasize the area or the portion you need to relearn. Don't share the documentation with clients and use this documentation, that is milestone documentation, as the basis for wider documentation. Milestone documentation or otherwise checkpoint documentation is the first set of documentation. You can repeat your work using intermediate files and you can recreate documentation. And usually milestone is the start of a project. So what is Knitr? Knitr is a R package that includes R code. So inside the documentation, milestone documentation, we can include R code. Actually, this Knitter's operation is similar to this literate programming and adds usage package. Usually, it maintains a master file that contains both user-readable documentation and chunks of program source code. Documentation type supported by Knitr include LaTeX, Markdown, and HTML. HTML format is a good choice for detailed typeset technical documents. Markdown format is a good choice for online documentation and wikis. Direct HTML format may be appropriate for some web applications. Knitter's main operation is knit. It executes all the R code and builds new result based on the contents of the original document, and it will print the code as well as result. Okay, using Knitr, how to create a documentation. In the initial document is either .rnw, it is a LaTeX format, and if it is a markdown format, it is RMD. We will be studying creation of these type of files later. So in the initial file, we will be having a documentation chunk. This documentation chunk means it is a just user written documentation. This will be copied into the Knitr result documentation. After that, there is R code chunk. This R code chunk will be converted to pre-printed R code chunk and as well as the result. Pre-printed and result. Then again documentation chunk. Documentation chunk is converted to documentation chunk. It's just copied to the Knitr result. Then again R code is converted into pretty code R code chunk and R execution result. Then again documentation chunk is copied to the Knitr result. So this is the schematic diagram. A simple Knitr markdown. Markdown Markdown is a simple web-ready format that is used in many wikis. Usually, a knitted annotation document is denoted with these three quotes. Actually, there is no full stop here. So, knitted annotation blocks are denoted using three quotes. How to create knitted documentation? Sorry, milestone documentation using knitted. So actually, the file name is like this. kn. kn specifies the file name and .rmd represents that it is a markdown file. R markdown. Okay. So here we are discussing two examples. That is, this example is using for plot and another example is using for calculation. So first we are using a plot example. So here we are using a ggplot, and ggplot data frame, we need to plot this line. The command we had already studied. And after that, remember that this knitted documentation starts with the three chords. And after that, another example, calculation, knitted starts with the three dots. Then here one calculation is there, pi into pi. It is a calculation example. So in order to run the knitted file, select knit to HTML, or you can run the code from the command line. Okay, here from this button, you can, if you click this button, you will get a pop-down window like this. You just check knit to HTML to run this file. If you run this file, these are the documentation which is typed before the code. It will be printed here. And a pretty R code is printed as well as the result is also printed. Then about the next example, this one is the documentation. This is the R code and result of this pi into pi is printed here. That is 9.81. This is an example for a simple markdown. You can also open the result in browser or publish it. Next one is LaTeX example. LaTeX is a powerful documentation preparing system suitable for publication quality typesetting. And main new feature is that in LaTeX, blocks are marked with this symbol and this @ symbol instead of these codes. Okay, next is using command line. You can run the knitted documentation from the command line instead of clicking that knitted to HTML. So you have to type the whole file in the script area and save it as simple.rmd. Simple.rmd is in the current directory. In order to check the current directory, you can just look at the file panel, which is located at the right portion of the RStudio. Otherwise, you can issue a command get WD, get working directory. Okay, this one is the console panel, and here in this panel you can set the current directory. These are the steps in the console panel, and finally you will get an output kn.md. This is the final output file result. This produces a new file simple.md, which is in a markdown format. This md means it is markdown format. Okay, run it using this command r with the option -e r markdown render kn rmd in the command prompt. Type this command in the command prompt. Save this content into a file called add.rnw and then run r in batch to produce the file add.txt. At the shell, when we then run LaTeX to create a final output add.pdf, or use the command line prompt like this: r script -e library nit add rnw. After that, the output will be a LaTeX file. You need to convert this LaTeX file to PDF. For that, this command is used for converting LaTeX to PDF. In order to convert LaTeX file to PDF, you have to issue PDF LaTeX add text. Okay, this one is the screenshot to run the RNW file, and this one will create a PDF add.pdf from add.text. Add.text is created here. Add.text. This is a simple and neater example. You will get a R code like this, and the result will be like this. Actually, result is this one. Actually, the purpose of knitter is to produce reproducible work. You can distribute your work, and anyone can download it and rerun it and check whether they obtain the same result as that of the original author. As it is an ideal documentation purpose, scientists won't share their actual code, data, and actual procedure. So, the actual goal of this knitted documentation is never met. Knitted collects and automates all your work, but if something is missing, then it won't work. Actually, the essential work makes our work easier. Maintenance task made by knitted. First one is keeping code in sync with the documentation. We are keeping only one copy of the code, so it is not so easy to get out of sync. Our code will be in sync only. Next one is keeping results in sync with the data. Here we are eliminating all by hand steps, so it is easy to rerun and recheck your work. Then handing off correct work to others. So if the steps are sequenced using a machine, It is if the master record hold all your data, it makes your work much easier. Okay, to use knitter, you need to know how the knitter code works. So you also need to know how the chunks are marked and what common chunk options are needed to manipulate it. Knitter block declaration format. So a knitter code starts with 3 codes. After that, the first name is the name of the block, and after that you have to give some comma separated option value, that is chunk options. Knitter chunk options. First option name is cache. So controls whether the results are cached. With cache equal to F, the code chunk is always executed. With cache equal to T, the code chunk isn't executed. Next option is echo. Echo means source code is copied into the document. If echo equal to T means pre-formatted code is added to the document. If it is F, code isn't added to the document. Next option is EVAL. It controls whether the code is evaluated. EVAL equal to T means the code is executed, and if it is equal to false means it is not used. Next option is message. Set message equal to F to direct our message commands to the console running R instead of to the document. If it is true means it will be pushed to the document only. Result. It controls what is to be written with R output. Results equal to within inverted comma hide suppresses the output. Next option is tidy. It controls whether the source code is reformatted before being printed. Tidy equal to for F means current version of knitter being break code due to mishandling of R comments. So how to use knitter to document the bus data. First step is setting up chunk cache dependencies. After that, you have to confirm data provenance. It is followed by recording the performance of naive analysis and finally using milestones to save them. Using knitter to document the bus data. Use knit to document the initial trivial model. Bus is the record of computer discussion topics. We had discussed it earlier. What are the parameters of, what are the fields of this bus data? We had already discussed it. And it produces a document which outlines the initial steps of working, and it is followed by the caching and its advanced formatting. First example is in Markdown format, and it is file name is bus.m.rmd. It knits to the Markdown file bus.m.md. Second example is in LaTeX format bus.rnw. It knits to the LaTeX file bus.text, and it produces a viewable format using PDF LaTeX, and the output will be bus.pdf. Bus.rme and bus.rmw R and W uses different delimiters as shown here. These are the delimiters. Meter cache. For a meter project, you need to enable the caching. Rerunning meter is expensive. So enabling meter caching is done using cache equal to T. To set up chunk cache dependency, insert the following invisible chunk at the top of the file. So use this at the top of the file so that the chunk options will be invisible. In order to set up the meter dependency option, these are the commands and these are the cache options to be used. You can see that this one is T. So here we can view certain options. So let us explain what is this tidy, echo, cells, etc. So next is confirming data provenance. Because meter is automating steps, you need to confirm the data you are analyzing. For example, in bus data analysis, you have to confirm it using SHA cryptography hash function. If the hash function matches, then the data downloaded is a confirmed one. This is done using the following list, using the chunk option as cache equal to T. So this will be the screenshot. You can see that this cache equal to T here. And you can use a system command paste SHA in file. What is in file? In the in file, you are saving the text data. So you are checking this SHA cryptographic hash function of the file using this command. And after that, if this one matches, then you will read the database into bus data. The data we loaded has the same cryptographic hash we recorded, and if you are working with the same data, then it will speed up the debugging process. Okay, you can read the file and it is stored in file. After that, you can check the hash function and write down the file hash function. Here it is, write down. If it matches, then you can proceed. Okay, next step is recording the performance of naive analysis. The initial milestone will record the result of the naive method, naive model. For example, in the bus data analysis, we can use random forest modeling and apply the model to test the data. So this is an example. Actually, this is modeling using random forest, and this one is the table. This bus test is the table, and bus is we are using an attribute, so we put a dollar here. In the bus test, there is an attribute bus. So we are checking the bus value. Okay, that bus value is stored in truth. So in the truth variable, we have the attribute bus which is present in the original table. And it is read as a data frame and it is stored in R-test. Okay, once you create a model, you need to predict the model. What do you mean by predicting? After creating a model, we need to test the model. Testing is done using this command, predict command. Okay, after predicting means to the model, you are created a model using random forest. To the model, we are applying some test data and test the accuracy. If accuracy is good, then your model is good. Okay, predicting the data means we need a model. Here, model is F model. And you need a data. Here, the data we are using is new data. Bus test. Okay, after that, we need to print the accuracy measures. Accuracy measure of what? We need the predicted value. Predicted value means R test is the predicted value. R test is the data in hand, and R test predict means it is the predicted value, and R test dollar truth. R test dollar truth is the original value. So original value is compared with the predicted value and check the accuracy. And this one is a screenshot. So we are having a precision value and recall value, and this one is a confusion matrix. Check the entries in the confusion matrix. You have positive, true positive, false negative, like that. After that, the model accuracy measures accuracy F1, DEB norm are also printed. Then using milestones to save the data. So there are lots of trouble in implementing write-up and running the bus data. So some additional analysis, for example, you can add better shape features for the time varying data. And it is done using, we had already saved the data in the workspace. So shape features, better shape features are introduced by extracting the values from the saved environment. And a conditional saving, and again conditional saving of the data, and again producing a cryptographic hash of the function, hash of the file. Data scientists starts their analysis on the saved workspace and produce some documentation. So this one is an example from save prepared documentation prepared using Knitter. So Knitter takeaway. So we have worked through various steps like load data, manage column, and perform initial analysis, present the result, and save a workspace. So after that, we need the output of the Knitter must be a nicely formatted documentation. It may be a bus.md, that is milestone data, bus markdown data, and bus.pdf. And next one is shared executable code, that is bus.rmd and bus.rnw. This makes debugging more easier and reliable. Next one is using comments and version control for controlling documentation. Okay, up to this we are creating a milestone document. Now we are using comments and version control. So running documentation using code comment and version control is very helpful. And version control is done using JIT. Writing effective comments in R, comments are usually done using a single hash symbol. So what are the qualities of a good comment? It includes what the function does, what type of arguments are expected to be, limits of domain, why you should care about the function, and where it is from. Comments must include all these things. Okay, another two important point to be noted is NB or to do notes. NB means not a been or not well. It means it will document any unexpected features or limitations in your code. For example, in R, variables don't have any types. So in the documentation, you have to document the type of the variables and its argument. Also, if a function, sometimes some function may not work correctly on list, data frames, etc. So it must be correctly documented. So this is an example. Here, these are the comments. Comments start with a hash symbol. Okay, things to be noted about comments. First one is pretty ASCII art formatting. So comments be there and it must be readable to format into a beautiful block. Next one is anything we see in the code itself. For example, sometimes in command we will be repeating the name of the function. It is not needed. There is no point of such documentation. So you can write it as a function needs just one argument. Anything we get from version control. Usually we don't worry to record the author or date when the code is written like that. Usually we will get it using a comment with JIT blame. So next one is any sort of Java doc deoxygen style annotations. This formally document R function is in .rt files. So avoid useless commands that add no actual content. For example, you can use this one can be avoided because from this code we can view that add one is the function name or this thing we will get it from the JIT. So no need of these commands. Next one is using version control to record history. Version control can both maintain critical snapshot of your work and produce running documentation. So this is an example. For example, suppose you are working on a project and you are working from Monday to Friday. Monday you will try something. Without version control, you will try something and it will be lost. And Tuesday also you tried something. Wednesday you tried some other brilliant idea. Friday, Thursday it is failed. Friday also it is failed. Then what will happen if you are using with version control? First try will be noted, second try will be noted. You will get all these versions from the version if you are using version control. JIT commands. These commands are very important one. JIT init, JIT add -a, JIT commit, JIT status, JIT log, JIT diff, JIT checkout. This will be one essay question. Okay, choosing a project directory structure. A pattern that is worked well for us is to start a new project with the directory structure. Okay, possible directory structure. First one, data. Data means we have served the original downloaded data. So exclude the version control from this downloaded data. Script is another directory where we store all the codes related to the data analysis. Derived is another directory where we store the intermediate results that are derived from data and scripts. Results where the directory holds the smaller results and handwritten content. This includes saved model, graphs, and reports. Starting a JIT project using the command line. Okay, you can start a version controlled project using start a project in a new directory, place all your work in the subdirectories, and then use type JIT init in the command prompt in the terminal. That is not in the RStudio terminal. You can use the ordinary Ubuntu terminal. Okay. That means those from them. Exclude any subdirectories you don't want under source control with the JIT ignore control files. So JIT init means you have, before issuing JIT init, you have to include all the directories into your project directory. And if you want to exclude any subdirectories, you have to include a .JIT ignore control file. Okay, next is JIT apt JIT status. You can check if you have already performed the init step by typing JIT status. Init hasn't done means you will get a fatal error. Usually, JIT repository is given as .JIT. If it has been done, then you will get a message telling that you have a branch master and listing the facts about many file. So once after issuing the JIT init, you can issue JIT status to check whether init has been done. The init step sets up in your directory a single hidden file tree called .JIT and prepares you to keep extra copies of file. Keeping all extra copies is called versioning. So once you start a project, you can issue a JIT init command. After that, no need to issue JIT init command. Issuing a JIT init command a second time is harmless. Checking in a file is splitting into two stages, add and commit. So first step is JIT init. After that, you can check the status using JIT status. After that, you have to issue commit command, where you enter a comment as to what you are up to. Then use update comment. You can run, add or commit pair of comments After every minor changes on your project, you can run these commands every time you leave the project. So these are the screenshots. So JIT add minus a means the stage result to commit what files to be committed. And commit means you are performing the commit. Okay, here you can see the history of this one. Commit means you will get a value and add export of random forest model. Then after that you can issue a commit. Commit, if you are issuing commit, you will get a value like this. Okay. Using JIT log and JIT status to view the progress. To know about the progress of the work, you can issue JIT status. JIT log to see the history of your work. For example, if you issue JIT status, so on branch manager, this is the output on branch manager. That means we are on the main directory. Nothing to commit. You didn't add anything. Okay, next one is using JIT through RStudio. The RStudio ID supplies GUI to JIT that should try add or commit cycle. So in RStudio, you can start a new project using create project like this. A screen will appear like this. After that, you can select click here, browse it and select the directory. After that, you can create. So you will get a JIT pan here. You will get other commands from here. Any file that is changed since the last time it was committed gets a line here. Okay, line here. Okay, then after creating the project, you can create new files. So you can commit your changes to version control. Select JIT control pan in the top right of the studio and it will show all the changed files. If there is a check box, there is a check in the checkbox for any file, then that stage is known as commit. So you need to, that means that you didn't commit that file. So you have to click the commit function. Then next is JIT history. JIT history will show all the history of the commands in the JIT pane. Then JIT help, it will give you all the documentation about JIT. So you can share your work with others. Sharing is done either using push or pull command. Push or pull command is used to publish and receive updates. Version control points. Commit often. Regularly you have to commit your work. Since the primary version control is on your machine, you have to take a backup continuously. If your machine fails, your work has been backed up or shared, you will lose both the work and your version repository. That's why you need to back up your machine. Using version control to explore your work. So you have to add a pair of add or commit lines. It will help us to track your work, recover a deleted file, and compare two past versions of a file. So it can be sharing the files with collaborators, publicly sharing your work, or maintaining different branches are also possible. JIT help will give you usage information. Also, JIT log type JIT help log will help you to learn the commands usage. Finding out who wrote what and when. A good version control can produce a lot of documentation. Command JIT blame is an example. If you download the JIT repository, so you are downloading this JIT repository, and you can issue a command JIT clone and then run the command JIT blame readme.md. This will give you who had written the code and when. So output will be like this. JIT blame readmd will give a code like this. This means that John Mount, these persons use this code. JIT blame information takes each line of the file and prints who committed the file, when they committed, the line number and content. The prefix of the lines JIT commit hash. Viewing a detailed history of changes. So the main ways to view the detailed history of project are command line tools like JIT log graph name status or RStudio and GITK. For example, viewing the recent history of the repository can be done using by issuing the command JIT log command. So JIT log name graph name status will give you this output. This means who had committed, who is the author, when, what he had added, what are the changes done by him, then another commit, another author, what are the changes that are done by John, like that. Commit comments can be short. Update, instead of update the JIT records, what files were altered in each commit. GITK-GY always allows similar views and browsing through the detailed project history. So this is the GITK browsing history. Use JIT-def to compare files from different commits. So suppose you are sharing your work with your friend, and after some days you got confused which one is the better last version, like that. So you can compare your files after different commits. So JIT-diff compares any two committed version of the project. Commits are named using large hash function. As we seen before, commits is followed by a long numeric string. It is a hash key. But you are allowed to use prefix of the hashes as the name of the commits. For example, finding the difference in two versions of this file. So difference, we are finding the difference. So it will issue a command output like this. JIT commit and JIT branches. JIT commit represents a complete state of the directory tree at a given time. JIT branch represent a sequence of commit and changes as you move through the time. The next is JIT log. After some time to check when did we delete the file. Sometimes file will be deleted accidentally. So you are sharing with your friend and your friend got angry and he may delete it. There is one option to track it. So that option is git log. So it will give you when and how did that file get deleted. So this one is the command git log name status readme. So you will get commit after a hash. This one is a hash key. Then what the this author do, and after the next commit what this author is doing. So you will get all the details of the previous history and you can check whether who had deleted it. The file was deleted by Mauritius and composed of a pull request to change our text file. So we can view the content of this older file with git show 9534CF readme because this 9534CF is the prefix of the commit name. You can recover the copy using git checkout 9534CF. Then, is there any different ways to control the version? So, sharing your work with peers can be done using emailing zip file. Sometimes it will cause confusion. So, version control is the best way to share the work with peers. Additional commands such as git pull and git rebase and git push are useful in this case. Each worker has their own repository and a single common naked repository is used to coordinate. Usual way of sharing the workflows are continuously, that means you are working continuously, sometimes frequently, and every time you have to pull a copy of remote repository into your view or git pull and then you can use push pull like that. Don't try anything clever unless you are in a clean stage. Otherwise, you will lose the whole data. Setting up a remote repository relation. For two or more Git repositories to share your work, need to know each other through a relation called remote. So if you are sharing a remote repository, you must share your link with your friend. Git repository is able to share its work to a remote repository by push command and pick up your work from the remote repository by the pull command. So uploading is known as push command and downloading is known as pull command. This listing shows the declared remotes of the author's local copy of this file. Okay, git remote verbose. So it will show who had fetched it and who had pushed it. Its origin also. The remote relation is set when you create a copy of the repository using git clone. So one git project can be copied using the command git clone. Or you can set using git remote add command. In listing, the remote repository is called origin. A remote repository that you are using are your master or gold. Git tends not to use the name master for repositories because master is the name of the branch you are usually working with. That means master is the original file. Once your friend push that repository means the whole directory, whole project. Then it will be a branch only, not the master file. Master file means the originally created directory. Using push and pull to synchronize work with remote directories. Declaring some other directories, you can declare some other directories as removed. In that case, you can push and pull some directories between the repositories. Before pushing or pulling, make sure that you are in a clean state and you want to pull before you push. For simple tasks, we won't use branches. In that case, you have to use a rebase option. So for simple tasks, we are not pushing the branches. We are using rebase option. So some new JIT commands, JIT push. So its syntax is JIT push minus U origin master variation. JIT pull. It is used to fetch the JIT. So different versions are there. JIT fetch, JIT merge minus M pull, master origin or master, or JIT pull rebase origin. Two others may be working on different work, and for example, suppose you are working parallelly and second author want to push their result to the shared repository. So there will be some confusion when you are using a parallel work on the repository. Rebase is much simpler to read. You don't need to share the rebase work. You should avoid rebasing work since you are hiding the edit step they may be basing their work on. For most projects, you use a rebase only strategy. So initially we consider an example. A book is maintained in a JIT repository. Two authors may be using the copy of it. If you always rebase an option, the edit history will appear totally ordered. One is always recorded. Okay, JIT work, rebase function. So two workers are there. Worker A creating a file A and worker B creating a file B. Worker A pushes work to shared repository. So both are using a shared repository. And suppose B is trying to push, but A is working on it. So at that time, JIT refuses B because A is continuing its work. So worker B pulls from shared repository using JIT pull rebase. So in usual cases, he can't push it, pull it, not pulling, push it because A is working. So B pulls the shared repository using JIT pull rebase. And then worker B pushes the work to the shared directory. So after A is edit, it will push it into the shared directory. And parallelly, it is going to continue. Push and pull are done on the shared directory. Like that, it will continue. Deploying models, that is the fourth point. It shares a rule with good writing. After a successful completion of data science project, it includes a demonstration of deployment of any techniques and models. And other peoples are able to see how things are working and they are able to try their own test. So this will encourage partnering with a development group. So these are the methods. So first method is batch. So data is brought into R, scored, and then it is written back out. Next method is cross-linkage, cross-language linkage. R usually supplies answer to queries from another language and it uses efficient cross-language calling. Next one is services, and R can be set up as a HTTP service to take new data as the HTTP query and respond with result. Next method is export. Often model evaluation is simple compared to model construction, and project engineers, production engineers can implement different tests and model evaluation in their own language of choice, and they are able to export the model and the specification to evaluate the model. PMML is a predictive model markup language. It is a shared XML format that many modeling packages can export or import. You can export it without any additional coding. Deploying models can be done using two methods. First method is using R HTTP services and second method is using export. So first method for in the deploying models using R HTTP service. One easy way to demonstrate an R model in operation is to expose it as a HTTP service. For example, the previous example can be considered. Bus model is used to predict the discussion topic. This is an example. Here we are loading a library book. This book only uses, not book, Rook. R. Rook only import the HTTP server libraries. Then the data is loaded. This means data is loaded. After that, you are using a random forest model. So it is defined in the library random forest. Load random forest library and loading the workspace doesn't load the library. Okay, then so we need to determine which variables are numeric. So this one is numeric. Function will check which variables in our root server are numeric values. Then after that, it is supply is used. What is the function of supply? Okay, we had studied it earlier. Okay, then after that, we are declaring a modeling service. Here we are declaring modeling service. So errors, warnings, value, columns, and if there is any error, it will be printed. This block does the actual work. So here, try catch is used here. Okay, here, first of all, ENV, it is parsed and it is converted to a list. As list means it is converted to a list. This argument, this ARG is converted into a list. Then this variable list is stored in names of row. Finally, after building the model, the model is a new test data is predicted using predict function. This X model is the model. This one is the model. And what is new data? This one is the test data. Okay, like that we will continue. Okay, then after that, certain warnings are produced. So this portion is for formatting. /n is there, you can check it. After that, register our model function as a HTTP service. So for that, you have to start a new rook HTTP service. It is done using $httpd$new. Then after that, you can add the model function because we are going to register the model. So this yes model is registered using start function is issued. After that, print the model. So result of this will be like this. Server is started on this one is IP followed by port. Then we can issue call browse to run the application. Okay, next one is how to call the HTTP service. Okay, it is using the function URL row. Function is used to convert a row of dataset into a huge HTML form that transmits all of the variable values to the HTTP server. So after that, you can use the function paste to pass the information. Then you can apply apply, means you are applying on the list. What to be applied? You are pasting some values. You are copying some values. So after that, this is the URL where the server is on, and use cat function which representing the variables for the seventh test example. This seventh test example to a file known as bus7.html. So output will be like this. So there will be one send here. Once you click the send, it will be submitted. So seventh test is checked. The generated file bus7.html contains a form element that has the action of HTTP this function as a post. You all know what is the function of post in HTML. When you use the send button on this page, all the filled content are submitted to the server. Once you issue send button, the contents are submitted to the server and we will get a classification result from the model. This HTML query can be submitted from anywhere and doesn't require this R. An example result is saved in GitHub as bus test7 res.text. So it will contain like this, value equal to 1. The result is a prediction of value equal to 1, which was what we had expected for the seventh row of the text data. Copy of R running the rook server is willing to classify examples. Such server can be used as part of large demonstration and allow non-R users to enter example data. If you are pushing this further, you would move more machine-friendly formats such as JSON. Okay, so running a code in Rook server means server need not have any knowledge of our programming language. It can enter the data just as a end user. Means he doesn't know what is R or its implementation. He just type a simple formula. And in that case, it is machine friendly. Formats are also available for pushing such kinds of data. Deploying models by export. Because training is a hard part of modeling a model, it is better to export a finished model. So creating a model is a difficult one. So after creating only we can check it. So in a company, sometimes for a particular event or a particular scenario, a expert will create a model. It will be a finished model. After that, we can use that finished model for some other, for the same subsequent scenarios. So, like how a random forest picks the variable and build a tree. The structure for our random forest is large, but it is a large collection of decision trees. So construction is time consuming. Once you have the model, you can do it fast. So exporting a copy of finished model from R instead of attempting to reproduce is easy for model construction. When exporting a model, you are depending on development partners to handle the hard portion of hardening a model. Software engineers tend to be good at project management and risk control. So development partners will create the most important model for production, and software engineers will be managing the project and its risk control, and so export projects are good. The steps required depend on the model and its data treatment. So for many models, say it need to save a few coefficients. For a random forest, you need to export the trees. So you must know the convenient programming language for writing the code in your target system and to evaluate the model. One of the issue of exporting model is that you must repeat any data treatment. So producing a specification of data treatment to export the bus random forest model and its documentation are accessible through a method called getTree. So in the following listing, we can combine the description of all these trees. Okay, load the saved data using this load. Then this one is loading the library, random forest library, so that we can create a model using random forest model. So after that, this is a function that joins tree tables from the random forest using the function getTree. So after that, you can write the table as a tab separated value table, and this is used for further evaluation. So a model is created and it is stored as a table. A random forest is a collection of decision tree and it shows a single tree from the bus random forest model. A decision tree is a series of tests traditionally visualized as a diagram of decision trees. The content of decision tree is easy to store in a table where each table represents the facts about decision nodes and the level of test and the IDs. To implement a random forest model, one has to write the code to accept the table representation of all the trees in the random forest model and trees through the specified test. Okay, what is a decision random forest? Random forest is a collection of decision tree. What do you mean by decision tree? Decision tree means there will be a set of nodes and there will be a set of edges. In the nodes, we will be storing the attributes, and a decision is considered at each and every node, and after that, based on the decision, some actions have to be taken. And these results are stored in a table. So random forest is a collection of decision trees. That means actually the decision tree will be like this. Set of nodes A, B, C. And some decision. If A is greater than 5, then it will be go to B. Less than 5, it will go to B. Greater than 5, it will be go to C. That is the decision tree. So collection of such this one is decision tree. So collection of such decision tree is random forest. So it is stored in a table. And we can use this table for implementation. In the case of random forest also, that is the advantage of using random forest. So developer partner use the build tools to read the model and evaluate the trees on new data. So after building the model, so once you create the model, you have to test it. You have to test it using test data. So this is done by a developer partner. And he will evaluate the tree. And he may have the previous results and demonstration server. And based on this result, based on the previous test result and demonstration server, he will evaluate the acceptance test.